Good morning. This is the e-learning video lesson for Honors Math 3 for section 14.2. So today we are going to talk about different algebraic techniques for finding limits for these different functions. But first, let's go ahead and do a couple of review problems. So here we're trying to find the limit of this function as x approaches 0. Then again, you notice that this function is undefined at 0. If you were to plug 0 in for x in the denominator, then the function is undefined. So we cannot approach finding the limit in that way. So again, what we're going to do is we're going to do the calculator method here. So let's go ahead and enter that function into our calculator. Okay, again, you want to make sure, because we're using trig as part of this function, that you are in radian mode. All right, so we want to try to find the limit of this function using a table. Okay, so let's go to table set. Go ahead and do our initial starting value for our table at -0.1. I'm going to change our table to 0.01 for the table change, and then go to our table. Alright, so again, approaching 0 from the left. So you notice again, as we scroll down here, our y values are steadily growing. Alright, again, as we get closer to the x value of 0, alright, you see it's still growing, and when we get to 0, we get our error message. Again, we are expecting that because our function is undefined at 0. Alright, so if I scroll down a little bit more, alright, so again, we see here as we start at 0.04 and we come into 0 from the right, that our y values, our output values, are shrinking slightly. Alright, so coming in from the left, coming in from the right, we see that as x approaches 0, our output is getting closer and closer to 1. So that is our limit for this function. As x approaches 0, it is equal to 1. Now we look at example number 2. All right, we're trying to find the limit of this function as x approaches 3. Now you notice that when we plug in 3 for x, our function is defined. Okay, so for these type of functions where we're trying to find the limit for, the way you find the limit is by simply plugging in that value. And when we do, plug 2 and 3 in for x, do the math, and we get 19. So the limit of this function as x approaches 3 is 19. Alright, so now we're going to move on and talk about a few other properties of limits that can help us easily evaluate these limits. So now we're going to first look at limits of functions that are a constant. So for example, if a function is defined as some value b, right, then the limit as x approaches some value c for that function is just going to be that constant value of b. Okay. Just trying to find the limit of a function that is an identity. All right, that is an identity function. So for example, if f of x is equal to x, then the limit as x approaches some value c for that particular function is going to equal that c value. Okay, so let's go over a few examples that will use these properties. Finding the limit of this function that is defined by this constant 8 as x approaches 2, and using the first property, finding the limit of a function that's a constant. According to that property, right, the limit is just that constant value. So the limit of this function that is defined by this constant 8 as x approaches 2 is just 8. Okay. Finding the limit of the function that's defined by this variable x. Okay, so that would be the limit of the identity function. Right? If the function is just x according to this property. The limit as x approaches c of this function is just c. So the limit of this function x as x approaches -2 is equal to -2. Finding the limit as x approaches 0 for this function, which is defined by this value of -5. That's a constant. So that's the limit of a constant. So that would equal -5 according to this property. Alright, so if f and g are both functions for which we can find the limits for each of those functions, if both limits exist, then we can find the limit of a sum, difference, or product of those two functions. So, for example, trying to find the limit as x approaches c for the sum of these two functions. That is the same thing as finding the limit of each function separately as x approaches c, and then adding them together. Same thing happens with the difference. If you're trying to find the limit as x approaches c for the difference of these two functions, that can be found by simply taking the limit of each function separately and then subtracting them. And you guessed it, as x approaches c for the product, trying to find a limit as x approaches c for the product of these two functions, you find the limit of each function separately using any other property. Then all you got to do is multiply those two limits together. So let's go ahead and apply those sum, difference, and product properties for limits. So here we're trying to find the limit as x approaches 3 for this function. And one approach that you can take is go ahead and split it up. Find the limit of this of x as x approaches 3. Find the limit of this function as defined by this constant 7 as x approaches 3. So again, using those properties, the limit as x approaches 3 of x is 3. The limit of 7 as x approaches 3 is 7. So add those together and we get 10. Find the limit as x approaches -2 for this function defined by -5x squared. So again, we're going to go ahead and that's a product. So we're going to break that up, and we're actually going to rewrite that as -5 times x times x. So we can use the extended version of that product rule. So that means we're trying to find the limit as x approaches -2 of -5. We're going to go ahead and multiply that limit to the limit as x approaches -2 of x. And multiply that by the limit as x approaches -2 of x again. Alright, so find that property from the previous part of the notes. This is -5. This is -2. This is -2. So multiplying those together, we all get the limit of this function as x approaches -2 is -20. Alright, so this next property, finding the limits of monomials and limits of polynomial functions. Okay, so we're going to understand that a is a constant. So finding the limit of a function as x approaches c if your function is a monomial, like a times x to the n. To find the limit for that particular function that is a monomial, you evaluate it as a times c to the n. Right? Again, as x approaches c for this limit, right, for ax to the n, you're going to evaluate it by plugging c in for x. Find the limit of a polynomial. Okay, so the limit as x approaches c. All right, so again, polynomial meaning many terms. Okay, so again, a's are our coefficients or our constants. Here's our variable x put to some exponent. To find the limit of this polynomial function as x approaches c, to find that limit, as you can see here, all you're doing is plugging in c in for x. Alright, so let's go ahead and apply those properties in the next two examples. So here we want to find the limit of this function as x approaches -3, and our function is a monomial. So according to this property, to find that limit, all you have to do is plug -3 in for x. Alright, so the limit of this function as x approaches -3 is -54. The next, we're trying to find the limit of this function as x approaches 2. We notice that our function is a polynomial. And again, according to this property, to find the limit of this function, which is defined by a polynomial, all we have to do is plug 2 in for x. And then evaluate. Alright, so this last property we're going to go over, we need to make sure that when we're applying these particular properties, that we understand that if the limit of a function as x approaches c exists, right? So the limit must exist for these properties to be in play. Right? So if the limit of our function as x approaches c exists, then the limit of this function as x approaches c, where the function is put to some power n, you can find that by simply taking the limit of this function as x approaches c, finding that limit, and then putting that value to the n exponent. Very similar manner here, we're trying to find the limit of this function as x approaches c, where the function has a radical around it. To evaluate that, you simply find the value of the limit of that function, whatever it is, and then you put it to that root. Alright, so for the first example here, we have the limit of a function, alright, put to some exponent. Alright, so it's using this. So what we need to do is we're going to first evaluate, find the limit as x approaches 3 for 3x minus 1. So we know that that is a polynomial, so we just plug 3 in for x. So when we do that, this is going to give us 8. And the limit as x approaches 3 for this function is just 8. Then we go ahead and apply the property, and we're going to put 8 to the 2/3 power, and that equals 4. Okay, so for this last one, we are finding the limit of a function that's put underneath a radical. So again, to find that, we are going to first evaluate this limit as x approaches 2 for this function. So again, it's a polynomial. So all we got to do is plug 2 in for x. All right, so we find this limit for this function, and that's 9. All right, plug 2 in for x. You get 9. And according to this property, now we just need to take the square root of that, and that equals 3. So the limit of this function as x approaches 2 is 3. Alright, so make sure again that you are doing the book problems on a separate sheet of paper. Make sure you're showing all your work. Again, if you have any questions, please let me know. Alright, you guys have a great day.